All right, thank you everybody. Thanks Yusuf for the intro. Really appreciate you guys being here, closing out HashiConf with me. So a little bit about myself. My name is Maksim Frenkel, and I'm a delivery enablement principal with Fannie Mae. Primary focuses on Terraform infrastructure as code, as well as Sentinel policy. And I'm part of a team that's responsible for enabling our application developers to provision cloud infrastructure in a secure and compliant way so that they can then deliver their business applications to serve Fannie Mae's mission of facilitating equitable and sustainable access to homeownership. A few key topics we'll cover today. We'll look at Terraform Enterprise at Fannie Mae, and then we'll do a brief overview of Sentinel policy as code, what it is. And then we'll spend the most time on our policy development lifecycle, just to give you a framework for how you two can structure your policy development and actually get up and running developing policies. And then we'll wrap everything up with some lessons learned, some basic do's and don'ts, things that we learned over the course of our own development journey. All right, so just a quick overview. At Fannie Mae, we adopted Terraform Enterprise as part of our digital transformation. And as you can see, it's been a multi-year journey, adoption growing year over year. And we're at about 700 plus active workspaces now, and these belong to our application development teams, doing deployments through all life cycles, development through production. And in Terraform Enterprise, we've enabled roughly 80 or so AWS services for those teams to consume. We are primarily an AWS shop. And so in addition to those services, we've also developed roughly 450, we're at about 470 now, policies to guardrail the consumption of those AWS services, make sure that they're consumed in a secure way. And so being that we are in a regulated financial industry, as you can imagine, we derive our cloud security standards from any number of the compliance frameworks that are available. So you could see NIST, CIS benchmarks, we have data protection policies that come from FIPS, as well as Zero Trust, of course. And so you can see the importance with all of these different compliance frameworks and all the different controls that to guardrail all of our infrastructure and make sure that our development environments are provisioned with all of these compliance requirements baked in. And so this is really where Sentinel comes in, right? And for anyone who hasn't used it or who isn't familiar, Sentinel is HashiCorp's policy as code framework. And it's part of Terraform Enterprise, or HCP. And what it does is enable fine-grained policy decisions to be taken during your infrastructure provisioning. And being that it is policy as code, everything's managed through version control, so you can use very standard Git workflows. And being that you're using Git, everything's managed out of a repo. It lends itself very well to automated testing frameworks, build pipelines, release pipelines, you name it. And so most importantly, Sentinel is embedded in the infrastructure provisioning lifecycle. So you can see that it sits between the plan and the apply phase and actually provides that preventative guardrail to make sure that your infrastructure actually meets all of your compliance requirements before you can actually provision your infrastructure. So what you're doing is shifting compliance left to your development teams. You're giving them that feedback as early on as possible, as early as their development environment. And you're actually asking them to take action to make sure that they make their infrastructure compliant before they actually go and promote it up to production, where you might have an issue with non-compliance. So at scale, you can imagine there are several categories of controls that you can start to develop for, and several categories that we typically develop our policies for. So you may have security controls, let's say derived from a data protection standard. So for example, making sure that resources that support it have encryption at rest enabled. So DynamoDB having server-side encryption enabled with the appropriate customer managed key. You may also have a logging standard, similar to making sure that any services that support CloudWatch logging, like ECS tasks, that your developers provision them with the appropriate CloudWatch logging enabled, with the right log groups, you name it. And then you might also have architectural requirements, things derived from your enterprise architecture patterns, making sure that certain resources, like load balancers, for example, that they're only provisioned into approved subnets and security groups. Oh, right. And then very important, resilience, of course. Making sure that, for example, like we do, that your RDS databases are provisioned in a highly available way. So in production, you might want to enforce the use of multi-AZ so that your databases could tolerate the failure of any one availability zone. And then last but not least, you might have FinOps requirements. So this is very important, making sure that you keep costs manageable. So you might want to enforce controls around certain instance types and make sure that the more expensive instance types are only by approval, or that they're just, users can't deploy them. And so with that brief intro, what we'll do is we'll take a look at the policy development lifecycle, how we manage our policy development, and really give you a framework for how you can also get started, right? And so the first step, and what I would say is probably the most important step, is going to be around your requirements gathering. And so here you're going to engage all of your stakeholders. You're going to decide what service the control is affecting. And so we'll start with a real-world example here. So let's say in your organization, you're enabling DynamoDB as a service for your development teams to start consuming. But before you enable the service, you want to make sure that it meets your data protection standards. So making sure that server-side encryption is in fact enabled and that your customer managed key is set appropriately. So the very first thing we do, and very helpful, is to hop over to the Terraform registry, HashiCorp's documentation for the resource. And what you're going to want to do is understand what are the resources that are involved in this particular control. So in this case, we'll have a DynamoDB table. You'll also want to look at any attributes you might be interested, any attributes responsible for enforcing the control. And so here you'll see server-side enabled. We have also the KMS key ARN. And so what all this should boil down to is you should start getting like a very prescriptive specification for what your policy should look like. So again, you'll have your resource type, you'll have your attributes, and then you'll also want to define the allowed values and define what you want to enforce in the actual policy, making sure that enabled is set to true, that your KMS key ARN is set to an allowed value. In our case, for this example, we'll say that it has to come from an approved SSM parameter that holds the KMS key ARN. And then the enforcement level, I didn't go too deeply into this, but there are 3 enforcement levels. Hard mandatory basically makes sure that the policy is enforced no matter what, that your user community has to adhere to this control, that there's no override, and it's not a warning. They absolutely have to meet this requirement. All right, so we got the requirements for our policy spec'd out, and we're going to go now to the fun part, which is, of course, development. And so, being that it is a standard Git workflow, we have very standard feature branch methodology. We're going to start with a feature branch for that particular policy, or any change to your policy set for that matter. And then ultimately what we're going to do is merge that back into our release branch, which is what Sentinel is going to be using for the policy set. So hop over to our handy VS Code. We're going to start with developing a policy. And so here we're going to start with our basic Sentinel file for DynamoDB 001, which is going to be our policy for this control. And when you start developing, there's basically, I would say, 4 important sections for policy development. So the very first section is, of course, imports, where you're going to want to import any of the standard functions or shared functions that contain logic that are going to be shared across different policies. So in this case, you might have some out-of-box functions, like a tfplan v2, which lets you process all of your different resources in the plan and be able to actually extract information about them. But then you might also have custom functions, things like a context function, which will have information about the environment you're running into or the application that's responsible for the deployment. And then, of course, maybe like an SSM function if you want to look up the value of an SSM parameter to support policy enforcement. So now that we have our imports taken care of, the very next thing, what we're going to look at is resource import. And so here, you're really just going to define what resources you're interested in the policy. And so here, you're using your tfplan function to import and filter for your DynamoDB table resources. And similarly, we're going to use that SSM function we just imported in the previous slide, and we're going to go and get the SSM parameter value that we're going to use to enforce the policy. So we've got our resources identified. We filtered them out of the plan. The very next thing is to actually write your policy logic. So what do you want the policy to do? And we found it pretty useful to encapsulate that logic in a single function or multiple functions. And the functions are basically responsible for processing a single resource at a time and inspecting for all of the different checks that you would like to do as part of this policy. So first thing we'll do is look to make sure that our DynamoDB table has our server-side encryption block actually configured. And of course, we'll return an error and return false if it's not configured, or the length of it is 0. There's no sub-arguments. So we really want to fail on this check. Next thing we'll do is, assuming that server-side encryption is in fact configured, we're going to look at our enabled value and see if enabled is in fact equal to true or false. And if it's false, we'll again return an error, and we'll append that to a results list that we'll process at the very end. And then the very third check we're going to do as part of this policy is we're going to validate the actual KMS key. So we're going to look to see, does the KMS key ARN for the resource actually match the allowed value we've pulled from SSM? And then we're going to take all that information, we're going to actually run it through and look at all of our results for all the different checks. And if any one of the checks actually did not pass, then we want this function to return false, meaning that that resource didn't actually pass validation. So we want to stop the policy right there. And then we're going to tie everything together with a main rule. And this is basically the last part of the policy. This is the part that Sentinel actually looks at to decide what it's going to be doing. And so here you're going to tie together your resource lookups, and you're going to loop on all the resources. And then you're going to actually run them through your validate function. And you're going to pass the resource. And this rule should return true or false. That's the expected outcome. And true, meaning that it's passing, all of your resources have in fact passed the check. And if any one or more resources doesn't pass the check, it'll return false. And your rule will return false. Policy will fail. All right, so that pretty much covers the policy development itself. The very next thing you're going to want to do is update your environment file. And this is basically just a Sentinel file that defines what policies you're actually enforcing as part of the policy set. So here you can see we're releasing a policy, AWS DynamoDB 001. And we also have a source, a link to where that policy file is held. So this is the one that we just developed. And then, of course, we're also going to say what is our enforcement level. So in this case, per the requirements, we're going to do hard mandatory, make sure that that policy is actually going to get enforced. All right. So that pretty much sums up development for this particular use case. It's pretty straightforward. The very next thing you're going to look at is, of course, testing, making sure that the policy actually works in the way that you expect it to work. And so here, kind of the crux of this step is to make sure that you define all the test cases that you want to test as part of this policy. So under what conditions should this policy pass? Under what conditions should this policy fail? And then being able to generate tests to be able to actually validate that and gain confidence that your policy is actually behaving as expected. So there's really two different tools for doing this. The very first tool is going to be Sentinel mocks. And these are just exports of a real Terraform plan, mimicking real world conditions, where you actually can see what's going to be happening as part of that plan, all the resources that are being changed, and being able to evaluate that against the policy to see if it behaves as expected. And then, of course, we'll have Sentinel CLI, which is a utility that Hashi makes available. And what that does is just lets you test a mock against the policy so that you can actually understand whether or not that mock passes or fails based on your requirements. So hopping over to a Terraform plan here, pretty straightforward. We have two DynamoDB table resources that we're creating. And right at the bottom of every plan, if you have Sentinel enabled, you'll see a button here to download the Sentinel mock. And what that'll do is download a set of files that represent this run. And you can use to actually test your policies to see if it behaves as expected. So inside of the Sentinel mock, you can see it's just a set of files. And every one of these files has its own unique use case for various types of policies. But in the interest of time, we're going to focus on the one that you'll end up using the most, which is the tfplan v2 file. And so most policies will end up using this because the tfplan v2 file has important information like what resources are being changed, all of your different operations being taken on that resource, like create, no-op, update. You can see resources being deleted, recreated. And so from there, you can also see the attributes and the state of the resource before and after the change. So you can actually see what's being done to a resource that already exists and actually understand what's going to be its intended state after the apply completes. So generating a mock for our pass case. And what I'm going to do is show you an excerpt of a tfplan file, because these do get pretty unmanageable. They're sometimes in the thousands of lines long. But just to highlight the important sections, this mock was generated off of a Terraform configuration with a DynamoDB resource that meets all of our requirements, right? So you can see there's a create action being taken on a DynamoDB resource. We have server-side encryption configured. We have enabled set to true, one of our other checkpoints in the policy. And then we're going to assume for this talk that this is actually the appropriate KMS key. This is the one that lines up to the SSM parameter value we're going to enforce. And so this is a pass mock that meets all of our requirements. Now, alternatively, what we're going to do is generate a Terraform plan for a resource that, in fact, doesn't meet our requirement. And so here, we'll download a fail mock, hop into the tfplan v2. And here you can see that we have a DynamoDB table resource being created, but server-side encryption is an empty block. So there's nothing there. Enabled is not set to true. KMS key ARN is not there. So this one shouldn't pass our policy. So once we've downloaded our mocks, the very next thing to do is to actually set up your test case files. And your test cases should be created one per mock that you're going to be testing, one per test case. And then the important sections inside of a test case are really a link to the mock that's going to be evaluating that test. So here you can see we have our passing test case linked up to our pass mock. And then you'll also want to import any custom functions or paths to any functions that are going to be required for executing your policy logic so that your test case knows what functions support that policy test. And so to just tie everything together, we've downloaded all of our mocks. We have one per test case. We have our test cases here linked up, linking our mocks to our policy. And then the very last step we're going to do is actually run our Sentinel CLI to actually execute the test. And so what we're doing here is saying Sentinel test, and we're passing in the policy that we'd like to test. That's going to go and execute all of our test cases that we've defined. And it's going to make sure that your fail case, the main rule returns false. Your pass case, the main rule returns true. And so ultimately what you want to see is that all of your test cases pass. So fail policies have failed, pass policies have passed. All right. So we have our policy developed. We've tested the policy, make sure it behaves as expected. And so the very next thing we're going to do is actually run through our review process. And so here we found it useful to have, two levels of code review. We have like a peer reviewer that is inside of the development team that can actually go and review, make sure the syntax looks correct, that it's written to best standards. But we also found it useful to have information security as part of our approval workflow, just to make sure that any policy changes, any changes to our policy set, mocks, test cases, everything runs through information security so they can really certify that all of your controls are being met and that you haven't actually changed anything. And then, of course, you're going to want a test pipeline to make sure that all of your test cases are passing. So for us, this could be as simple as executing Sentinel CLI. And we'll take a look at that in the next slide. So we're going to hop over to our handy pull request here in GitLab. And you can see that we follow like a very standard Jira workflow, one ticket per change to your policy set. And we know everybody loves their tickets. So at that point, we're going to look at the pull request. We're going to see that we actually validated all of our test cases. And so here, this is actually a gate before we can merge the pipeline, before we can merge the merge request, because we want to make sure not just that this policy's test cases have actually passed, but we want to make sure that if you made a change to a shared function or to another file in the repo, that you haven't had unintended consequences on another policy. So we test every single policy, every test case for every single policy to make sure that this PR actually will come through, not affect anything, and reduce the risk. And then, of course, we have our required approvals. And I just wanted to highlight kind of the strength of the code review process, right? So when you go to review, depending on how you structure your repo, you can see very clearly what policies are being changed as part of this. And you can also see that what test cases are being introduced. You can review, make sure that they link up to the appropriate mocks. And then you'll also see what mocks are being introduced and actually be able to look through the mocks and make sure that they represent the specific conditions that you're looking for those test cases. And then finally, you can also see changes to the environment file. If anybody changes the enforcement level or introduces a policy, removes a policy, all of that's going to be there as part of the code review. All right, so we've gotten through our review. Our merge request is approved. We've gotten through all of the change approvals, and all of our test cases have passed. So at this point, we're pretty much good to go. We're ready to go and merge it and release that policy. And so we'll merge the policy and hop over to Terraform Enterprise to take a look at our policy set. So this policy set is what you set up in Terraform Enterprise to actually tie Terraform to your policy set repo. And so here you can see we have a VCS connection going to our GitLab repo. Not pictured here, but you'll also be able to select what branch you want to monitor, and then also the location of your environment file where the policies and the enforcement levels live. And when you create that VCS connection, you also get a set of webhooks that basically on merge will update the policy set automatically as long as you're merging into that monitored branch. And so with this policy, we released it. And so you could see that the policy set has been updated. So the very last thing we'll take a look at is from a developer perspective. So what does this look like, right? We deployed the policy, and now we want to try to deploy a non-compliant resource and actually see what that guardrail looks like. So here we have a very simple DynamoDB table example. And our developer forgot to include server-side encryption, right? So this should not pass our policy. And when I went ahead and ran a Terraform apply, hopping over to our workspace, you can see that Sentinel policy hard failed. And it's actually a preventative guardrail. So your apply will not run. You cannot deploy your infrastructure unless it's compliant. So now let's double click on that real quick. So we'll take a look at the Sentinel policy. And your developers will be able to go into their workspace, into their run, and see exactly what policy is failing. And those error messages you provided them will actually be displayed here. So they can see what resource address is non-compliant. They could see what configuration is missing. And so here, you're going to want to really give them enough information so that they can go and resolve things themselves, so you're not getting a call at 2 a.m. and how do I resolve this, right? And of course, you'll see that the rule itself returned false, meaning that the policy didn't pass. So now I've gotten that feedback. So I need to go and configure server-side encryption. And I went and updated my configuration. And so now, running another Terraform apply, we can see that we are now all set. We have a plan with a single resource. Our Sentinel policy is passed, and our apply is now pending. So really making sure that this infrastructure meets all of our controls. Our data protection control has now been satisfied. All right, so that was a pretty simple example, but you can basically use this and cut and paste the whole process and just over and over iterate, create as many policies for any number of services. And so I'd like to talk now about some lessons learned through our kind of multi-year adoption journey. So the first thing I would stress is really the importance of requirements gathering, because your developers are really only going to be as productive as the requirements you give them. And you want to make sure you engage all your stakeholders early on, and you have enterprise architecture product owners for every service you enable in your Terraform Enterprise environment so that you can actually iron out the controls. What are the resources that are going to be reviewed as part of those controls, and what are their attributes? And the very next thing is policy performance considerations. So early on, we ran into this, which kind of precipitated the need for collecting some type of metric to see whether or not a policy change you've developed has introduced an unintended performance burden, right? It could take your policy processing from seconds. In our case, it took it to 10 minutes. And so we had to figure out exactly what happened, what policy change introduced it, maybe an import or a shared function. So definitely collect metrics on this and make sure that you're running different types of plans, different types of mocks, and seeing how long they run. And you also want to lean on shared functions a good bit. So these are basically functions that you can write that are repeatable logic that different types of policies can use. And you really prevent your policy developers from reinventing the wheel. And let's say in our case, an SSM lookup function, there should really only be one way that we look up an SSM parameter. We shouldn't expect different developers to do it different ways. And then, of course, policy backward compatibility. So just introducing a policy and making it hard mandatory may not be enough, because you have to consider not just new infrastructure you're creating, but you have to consider all the infrastructure that's already been created before it. And so you really want to make sure that you take that into consideration so you don't block your developers with a new requirement. And so you maybe want to put it into advisory first and have a life cycle around that before you promote it to hard mandatory and get everybody up to that compliance state. All right, so this concludes the talk. I just wanted to give some additional resources for you all to kind of get started with Sentinel. So of course, there's HashiCorp's documentation. That's been super helpful. And they also publish a public GitHub repo for all of their policy samples for most of the major cloud providers. And so here you can actually get an idea of how to write your own policies. And then the Sentinel playground is particularly useful if you don't have a Sentinel environment where you work. This is actually a web environment where you can go start developing Sentinel policies, start testing it against mocks, and actually start getting your hands on Sentinel, even if you don't necessarily have it available to you. Thank you guys for your time, and hope you enjoyed HashiConf. So.